Be greeted, guys. This is Elton from Maths and Science series. Today, I will take you to actually showing you how to answer questions in Newton's laws, specifically in Newton's second law, where we are required to do the calculations. So if you haven't watched the video or the lesson on Newton's laws, actually we separated them. We have Newton's first law, second law, and third law. So if you haven't watched them, make sure that you go there, guys, to watch it, so that you can that all of us can be in the same page. So this is what we're going to do now, guys. Okay, this is, as you can see, that this is physical sciences paper 1, grade 11, but even in grade 12 you can, it's running the same thing, so you can watch. We'll do different questions. This is November 2024 question paper. So here they're saying that a tow truck pulls a car along a gravel road. When you talk about a gravel road, we are actually talking about we know that there's frictional force. Okay, meaning that the surface is not smooth. Okay, then the force applied by the engine of the tow truck is 9,000 newtons. Then the mass of the tow truck is 1,300 kg and the mass of the car is 950 kg. The vehicles are connected. To each other by an inelastic tow bar of negligible mass. See the diagram below. So everything that's the statement is saying here, it's everything that's happening on the diagram. As you can see, this is the tow truck and this is the car. The tow truck, it has a mass of 1,300 kg and the car of 950 kg. The force applied is applied on the tow truck, not on the car. This is the tension force. Remember, if they ask you in an exam what is a tension force or tension, it is the force in a cord, or it's a cord connecting two objects or two blocks. Then the tow truck and car moves at a constant velocity. What is the meaning of that? When we have two objects, or since the tow truck and the car, they're saying that they are moving at the constant velocity, meaning that acceleration becomes zero. So whenever you see constant velocity under Newton's second law or under the calculations of Newton's laws, you must know that F net becomes zero. Why am I saying F net becomes zero? We have the formula that says F net equals ma. When we are actually moving, or when the objects are moving at a constant velocity, it means that the acceleration is zero. That will make the formula that says F net equals ma, it will be F net equals m times 0, which is F net equals 0. Do not forget that. So 5.1, they say that we must define the term frictional force. It is the force that opposes the motion. The force that opposes the motion of an object and which acts parallel to the surface. So this is how you should define a frictional force. Okay. 5.2, draw a label-free body diagram indicating all the forces acting on the tow truck. So the tow truck, okay, we are having 5 marks, meaning that the forces that must be present in our free body diagram, we must have 5 forces. Okay, 5.2, the free body diagram is indicated by what? By a dot. So this dot indicates what? The object. So this is the normal force. Why are we saying the normal force? Because the tow truck is in contact with the surface. If you haven't watched this video in our YouTube channel, make sure that you go there so that you can understand why we're saying that normal force exists. Then Fg, then we have the tension force, which is T, or rather Ft. Then this is the applied force, which is Fa. Now here, but they said 5 marks, meaning that I'll get a mark for this. 1, 2, 3, 4. We are only left with one force. But in a statement, they say that a tow truck pulls a car along a gravel road. In a gravel road, it tells us that we are actually having frictional force. Then frictional force will oppose the motion of the tow truck. Remember, the tow truck, the motion of an object goes to the left, meaning that the frictional force will oppose the motion, and it will go to the right. As we said, that the force that opposes the motion of an object, meaning that when an object goes to the left, then frictional force will go to the right. I don't know if you guys understand that. And I hope your teacher told you that frictional force and the force applied will not have equal magnitude. Okay, so now it will be 1, 2, 3, 4, 5. You got 5 marks. Now we have 7 marks here. Then 5.3. So here it was 5.2. Then here it's 5.3. Okay. 5.3, if the coefficient of kinetic friction, okay, they talked about kinetic friction, meaning that the frictional force is Fk. Okay, if the coefficient of kinetic friction between the tow truck tires and the road surface is 0.5, calculate the magnitude of the tension in the tow bar. Okay. Therefore, we are given the value, we are given the value of the coefficient of kinetic friction, which is mu k, between the tow truck tires and the road surface is 0.5. Then they say calculate the magnitude of the tension in the tow truck. So how is this? Okay, let me just write the formula. It will be F net equals ma, but we know that acceleration is 0, since they say that the tow truck and the car move at a constant velocity, meaning that F net will be equal to 0, because here we'll actually substitute 0, then m times 0, it will be 0. I don't know if you guys understand that, but that's very, very important. Then in our lesson, we said that the forces that are having an impact or effects on the net force are horizontal forces, meaning that on the F net part we'll actually put the horizontal forces, meaning that it will be negative Fa plus Fk plus T equals 0. But now we have the value of Fa on the tow truck, which is 9,000. It will be negative 9,000 plus. What's the value of Fk? So by the examiner gave us the coefficient of kinetic friction, meaning that we have this value. Before doing this, you will have to actually use this formula to calculate the value of Fk. But now, how can we get the value of Fk if we are not given the value of the normal force? Because we are only given 0.45 as the value of the coefficient of kinetic friction. Therefore, we'll calculate the normal force. It will be Fn equals mg. Then Fn equals mg. What's the mass of the tow truck? It's 1,300 kg multiplied by 9.8 equals okay, 1,300 multiplied by 9.8, we're getting 12,740 Newton. That's the value of the normal force. Therefore, now we can calculate the value of Fk, or where there's Fk, we can substitute mu Kn, or you can just substitute the value of mu k and the value of n, then you get the value of fk. Or you can just do this: mu k n plus t equals 0. Then it will be negative 9,000 plus the value of mu k, we said it's 0.45 times 12,740 plus the value of the tension equal 0. Therefore, you punch everything in your calculator, multiply by 12,740, going to get negative 3267 plus t equals 0. Therefore, you can take this number to the right, then we'll have positive t. We will have we just adjust we'll have positive t equals 3267 Newton, because t is also a force. I don't know if you guys understand this. So this is how you are required to calculate the tension of the magnitude of the tension in the tow bar. I don't know if you understand it. This is very, very important, guys. Okay, then 5.3.2 coefficient of, they say that you must calculate the coefficient of kinetic friction between the car tires and the road surface. You must calculate the coefficient. Remember, this coefficient, they're saying that if the coefficient of kinetic friction between the tow truck and the tires of the road is 0.45, meaning that the coefficient of kinetic friction between the car tires and the road surface is not equal to the coefficient of kinetic friction between the tow truck, tires, and the road. I don't know if you understand that. So this 0.45 here, it belongs, or it is the coefficient of kinetic friction of the tow truck, not of the car. So here we are required to calculate the magnitude, the magnitude of the coefficient of kinetic friction between the car, tires, and the road surface. Therefore, they're saying it's 5 marks, meaning that we must actually work here. We must actually work. Okay. But I trust you guys that you're going to get this correct, or you're going to get this right. Now, we have, okay, let me do this. Okay, this is what we're going to do. First, let us draw the free body diagram of the car. Then it will be Fn. Here we're going to have Fg, then the tension force as well as the Fk. All right, so these are the forces that are having an effect in the Fnet part, but we know that Fnet equals 0 because they are both actually moving at a constant velocity. All right, now what are we going to do here? Let us substitute the value of t. It's negative t plus fk equals 0. What is it that they're wanting us to solve? They want us to solve for mu k, or the coefficient of kinetic friction between the car tires and the road surface. So we're going to have negative t plus mu k n equals 0. Now we do not have the value of n. It will be easy for us to solve for mu k if we had the value of n, meaning that you have to calculate it first. Show everything in your calculations. It will be Fn equals mg. We only use this formula in this scenario only, because it's not always the formula that is going to be used, or the formula that is used to calculate the value of normal force. But in our lesson, if you haven't watched it, make sure that you go there and watch Newton's second law. Then you will get everything, how to calculate the normal force in different scenarios. Now M is 1000. Is it 1000? No, it's 950. 950 times 9.8. Then what's our answer? You punch 950 multiplied by 9.8, you get 9,310 newtons, not normal force, Newton. Therefore, the value of T here is equal to that one. They are equal but in opposite directions. So -3267 plus mu k multiplied by n, which is 9310 equal 0. Therefore, we can take this one and transpose it, meaning that we'll have 9310 mu k equals positive 3267. Then after this, we must actually divide both sides by 9310. Then these ones, they will cancel out. Then we're going to have to be 3267 divide by 9310, which is 0.04. So mu k or mu s, they do not have SI units. Why? Because when the teacher asks you, or when the examiner asks you why is mu k or mu s not having SI unit, it is because it is the ratio of two forces. For an example, let me say we have Fk, mu k, this is the formula, right? Then let us make mu k the subject of the formula. So we're going to divide both sides by n, both sides by n. Therefore, the SI unit of Fk is n. Then the SI unit for normal force is also n, equals mu k. Therefore, these SI units, they will cancel out, resulting that the mu k doesn't have SI unit. Why? Because it is the ratio, it is the division of two forces. I don't know if you guys understood that. So this is very, very important, guys, that you know this. I'm going to do another question, or a different question, but here of Newton's second law, or Newton's laws. So it's very, very important, guys. If you haven't watched that video, please go there, guys, and watch, and do not forget to like, share, comment and subscribe.